So here we can see that there is a cyclic element, because initially the value is less, then the value is increasing, then again the value is decreasing. You can see here, you can understand that this is known as autocorrelation, because here the data value that you are getting here, the series of data, it is regressed by actually itself. Okay, that means the past values, the recent past values has an, it is highly correlated with the present value, okay, or the latest value. So that here it is known as the autocorrelation, and here this is the random variation, because there is no specific pattern. Okay, this is just the random variation, but still we can see that there is an upward trend. Okay, uh, so uh, so this is all about the different types of data. Okay, so now uh, we will discuss another technique that is known as the exponential smoothing. Okay, so in case of exponential smoothing, what we can do, uh, you have seen, we have previously discussed on the weighted moving average method, and in case of exponential smoothing, a special type of weighted, this is actually a special type of weighted moving average method. Okay, so as you move towards the past data or the earlier data, you give less weightage to the earlier data. Okay, suppose here actually a value of alpha, this is known as a smoothing coefficient. Okay, so this value is actually here, it actually determines or the controls this particular process. Okay, so which is known as a smoothing constant. Okay, so you can see that along here in this graph, this is the weight. Along y-axis you are expressing, and along x-axis you are representing the periods. So the most recent data has been given the weightage of alpha. Then the next, the earlier data of the most recent data, it has been given the weightage of alpha into 1 minus alpha. Then again, the preceding data is given the weightage of alpha into 1 minus alpha square. Then then the preceding data is given the weightage of alpha into 1 minus alpha cube. So as you move towards the earlier data, continuously you are putting less weightage. Continuously you are putting less weightage to the earlier data. So this is actually known as the exponential smoothing method. And formally, the exponential smoothing equation is, it is given as ft plus 1 is equal to alpha into yt, or you can also tell it as dt. That means this is the actual demand, plus 1 minus alpha into ft, which is the forecasted demand. Okay. And ft plus 1, this is the forecasted demand for the next period, and alpha is the smoothing constant. Okay, so this can be also rewritten as ft plus 1 is equal to ft plus alpha into yt minus ft. Okay, So the implication of exponential smoothing can be better seen if the previous equation is expanded by replacing ft with its components as follows. So you write ft plus 1 is equal to alpha into yt plus 1 minus alpha into ft, okay, is equal to alpha into yt plus 1 minus alpha. Now you are placing the value of ft here. So eft, if ft1 plus ft plus 1 can be written like this, so ft can be written like alpha into yt minus 1 plus 1 minus alpha into ft minus 1. Okay, now if you multiply these things, like, you will be getting these kind of values. Now again, against ft minus 1 you can replace it using ft minus 2. Okay, so ultimately you will be ending up with having this kind of equation. And if you plug in all the values of, say for example, if you take alpha is equal to 0.9, then what will you will get? You will be getting this kind of values. You can see that the first, in this case it is alpha 0.9, then it is 0.72, then it is 0.576. So continuously you are giving the less weightage towards the earlier data. Okay, so this earlier equation, you can also rewrite it like this: ft is equal to 1 minus alpha ft minus 1 plus alpha into dt minus 1. You are replacing actually yt minus 1 by dt minus 1. That is, this is means demand for uh, the uh, the actual demand for the earlier period. Okay, so instead of ft plus 1 you are putting here ft. Okay, that's it. So now take a look at an example. Suppose you are given the 4 periods data. These are the actual demands. Now using exponential smoothing method, how can you forecast it? Okay, so here what rule we can use, we generally, we what we do, we do the that we consider that our the first value, assume f1 is equal to d1. Suppose alpha is equal to 0.3. Okay, and which is now first, in the first case you will assume that your forecasted demand will be actual demand, it will be equal to actual demand. So you put here 42. Then calculate f2, which is 1 minus alpha into f1 plus alpha into d1. So 1 minus 0.3 into 42, okay, plus 0.3 into 42. Okay, so the earlier forecasted value you are using to determine the forecasted value for the current period. Okay, this method you are using, so you are getting 42. So this 42 you will be using to calculate the forecast for the third period. Okay, so here also this forecasted value you will be using to calculate the forecasted value for the fourth period. So there you can understand. So ultimately your the fifth, for the fifth period, your forecasted value will come out to be 38.985. so you can understand that there is an approach of uh, there is an approach of the you are considering the difference between the actual demand and the forecasted demand. This sort of approach is there. Okay, so this you are considering or taking into account. Okay, so that's why the exponential smoothing method, it is better than the usually it is better than the earlier two methods. Okay, now another question is that how to understand the uh, how can you choose the uh, alpha value. Okay, so how to choose the alpha value? So here we can see how to choose alpha values. Okay, how to choose alpha value. Okay, so here how to choose alpha value. So we know that alpha value can be, it is a smoothing constant, and it must be between 0 to 1. Okay, so one way is, it is basically the alpha value is chosen usually using trial and error method. So for suppose example, you plug in the values of suppose 0 0.1, 0 0.2, 0 0.3 to up to 0 0.9. So a lot of values are given, and then the root mean square error is computed, and where you will get, in using the alpha value, where you will get the least RMSE or root mean square error, that value you actually use. Okay, to that value you particularly use for the you use. Okay, to choose the alpha. Okay, because what is root mean square error? It is nothing but, from the name itself you can understand that you plug in all these values, you calculate, you find out the difference between the actual value and the observed value. Okay, so that will be known as the error. Then you square it. Okay, so that will be actually the squared error, and you are taking the mean value because you are dividing it by n. Okay, and then you are doing the square root. So this is known as root mean squared error. Okay, so you calculate your root mean squared error to this is a measure. This is basically root mean square error. It is nothing but, this is a measure of your accuracy level. Okay, so in this way the alpha value is chosen. So now you forecasting accuracy measure. Okay, so how to do the forecasting accuracy? So suppose you use for to measure forecasting accuracy, you use the measures like mean absolute deviation, mean squared error, mean absolute percentage error, like this. Suppose you have got these actual demand and you have got these forecasted values. So you will be calculating what is the error, -5, 6, -6, -7, 6 error. So the absolute value or the mod values, then you will calculate, and then you will also calculate the error square values, and then you will be calculating the absolute percentage error. Okay, absolute percentage error values. Okay, if you take the averages of these values, for example these values, if you take the average, then it is known as the mean absolute deviation. Okay, if you calculate the averages of the error square values, that is known as mean square error. And if you take the mean the absolute percentage values average, then you will have mean absolute percentage error. This is mean absolute deviation. This is a mean square error. This is mean absolute percentage error. So in this way, you can measure your accuracy level. Okay. So okay, so I'm going to stop the